I'm Michael Ralph, and I'm the coordinator of the OMIIR group at Olathe East High School.
And my name is Ilya Tabak, and I'm a graduate fellow from the University of Kansas that spent some time with OMIIR this year.
We have both worked with the OMIIR group, which has been in existence for a couple of years, and our story has identified a couple of interesting questions related to doing research quality work at the high school level. Two questions in particular stand out. The first one that we wanted to address was, can high school students perform the critical thinking necessary to thrive in the unfamiliar conditions associated with addressing a question that has never been answered before? The second issue we needed to address was, do they have the analytical capability to collect data directed towards that question and then come up with an answer that is defensible in the scientific community at large? So I decided to tackle these questions several years ago, and I recruited some students to join me. So we started 2 years ago working in the summer with one cohort of 5 students who set out to answer the question, are there methanotrophic bacteria in the municipal water samples that we can obtain in Olathe, Kansas? That question was our single driving question over the course of that summer. All 5 of these students were graduated seniors. They had completed their high school work. They had all 5 been AP Biology participants, and so they had robust lab skills from their coursework during high school. So they're all highly capable students, and we all worked on this question for several months. They produced a data set that was not sufficient for publication, but it was sufficient to direct our work for the remainder of the program. This is still the central question of the lab to this day. And it was successful enough that we decided to continue this work into the following school year. The second cohort of students were all brand new again, but this time they were stratified across all the demographics available in a high school. We had freshmen to seniors with all range of science experience behind them, all working both on our central question of methanotroph presence, but then also their work diversified, and they began to ask some of their own questions and collect data to answer those questions as well. It was a different experience from the first cohort, but it was again successful, and so we continued our work into the second full school year, where this time the program really started to reach maturity, where we had veterans, which were students that had participated in the program in the past, as well as new students who had been recruited that year. And in this form, we had the greatest diversity of projects being participated in by these students. They were working with a number of stakeholders outside of the classroom, and at this point, we really started to identify could be a sustainable program moving forward, and so began to examine the underlying structure of how this lab came into existence. It really started in the first cohort with all students working towards one central question that was provided by me, the teacher. Our central question directed all of their work in that first summer, and everybody was focused towards one single answer. As we moved forward and students spent more time working, they started to identify some of their own questions, and so the work spread out and became more broad, with some students addressing questions that were still related to the central lab question, and some students even began asking some more independent questions that even moved outside the scope of what was being addressed in our initial methanotroph-based question.
And the landscape that I really came into this past school year is one that was a research lab that was housed in a secondary environment that was looking at a question focused at methanotrophic organisms, as well as supporting a number of other independent questions. And so we really spent some time, Michael and I, this year, analyzing what does an infrastructure look like to start to support that model. What's necessary in order to enable independent lab supported by a central question and containing other students to really connect with resources and be able to facilitate exploration and allow students to ask their own questions and really conduct scientifically rigorous inquiry of these questions. And so, as you might expect, there are a number of challenges that are unique, some of which are unique to the secondary settings, but none of which are insurmountable. Some attention should be directed toward finding overlapping schedules and providing enough resources and capability to address some of these, but they were overcome. There were some very, very interesting benefits, though, that this infrastructure and really this landscape allows. It's a really, really, really rich environment in which to explore the interplay between industry and academia. And so the students were able to reach out and connect with multiple players in that ecosystem and really understand how STEM is practiced in the real world. they were really able to stand up their analytical and critical thinking skills in order to be able to decompose a bigger question and really be able to investigate and determine some of the things that they would need in order to answer that question. They also really learn how to properly communicate their findings and really any topic to match their audience. And so they knew how to talk to their colleagues, other students. They knew how to talk to a general audience, and it was really interesting to see them develop this skill set. It's also an ecosystem in which you can see the integrated practice of the many different topics in both mathematical and scientific, and really see the curriculum come to life. In the secondary curriculum, this may not be as common of an opportunity, but it's a really, really rich context in which to see how things connect to each other.
And that last point is particularly relevant to teachers or other people working in the education space, because we have new standards coming across the country that emphasize students' ability to solve unique problems, to apply math skills and engineering skills, and ultimately we have always wanted to increase our engagement with students, especially students who may not picture themselves as primary candidates for professional researchers at the university level. Students that are engaged by the interesting questions or the unique nature of the work find that they may, after all, be somebody capable of contributing to the scientific community moving forward. And that's one of the greatest goals I've had so far. So in my opinion, all of these benefits greatly outweigh the challenges that we've encountered so far and lead me to believe that this work should be continued. So if you find yourself in any of these categories, if you're a teacher interested in starting your own program, if you're a practicing researcher who is both capable of contributing to our central question or maybe providing some new lines of inquiry for our students to pursue, or if you're an industry professional capable of supporting our primary directives or providing new problems on which our students can work, please reach out to me via email and let's find a way to work together.